Hello, my name is Todd Rothman. Welcome back to Organic Chemistry 1. In this video, we're going to learn about the chair form of cyclohexane. And by far, this is going to be the longest video of this three-section series. Okay, so here's where all the meat and potatoes of this whole conformation of cycloalkane comes in. So let's get started. And as you can see, here are the topics we're going to cover. You could read them. There's a bunch of topics. We're going to finish off with the problem-solving techniques, and that'll give you the mastery that you need, the confidence that you need for mastery. Okay, the first thing I want to talk about is how do you draw chair conformations? What do we do? And notice how I have this right here, this indication of a V and upside down V. That is what you want to look for. So when you're looking at a structure on paper, if you're having it drawn out for you, you're going to look for a V and an upside down V. And that's going to illustrate for you, the different points of this. Now, what happens is when you go through a ring flip, we're not going to look at the half chair or the twist and the half the half boat. What we're going to do is we're just going to go from chair to chair. And so after the ring flip, we've already done two things. We brought up the red and we pulled down the blue. So we're going like this, but we're only drawing it like this, and then we're drawing it like that. And so what we note here is that the V becomes an upside down V after the ring flip, and the upside down V over here, this blue one, becomes a V after the ring flip. Now, let me just show you how we would draw this out from scratch. What we would do is we take two lines. Let's say we start the first line here, and then you draw the next line where it begins after the first line and ends after the first line, the top line. And now you do a V and an upside down V. And then we do the opposite. So if we draw a line, now the bottom one begins before the top and it ends before the bottom. It ends before the top. So now we have a upside down V and a V. And that's it. So one more time, you draw two lines. Top one starts before the bottom, but the bottom ends after the top. V, upside down V. And then we have the top one. The bottom one starts before the top, but ends before the top one. Upside down. This is a V, and this is an upside down V. And that's it. So this is how you do your ring flip. Get comfortable drawing this because it really is important. Now, one other thing I want to add is that you'll do it on an angle, so you'll kind of draw it not a straight line, but like that, and so that will do it as well. So you kind of have it on, kind of on an angle here. All right, so that's how you draw this out, and what you're looking for, if it's already drawn out, is the V and the upside down V. All right, now it turns out, remember I had mentioned to you in the previous video the idea that there are it's because the molecule is three-dimensional, there are two different types of bonds that we're going to see. It's not going to be the same exact bond. So let's take a look at this molecule for a moment. I want you to take a look at something. Notice that right now, this is the ring, and I'm in my chair form. If I look at it from the side, or even let's just look at it from this point of view. So it's a little bit weird to see this, but look, this is a six-membered ring, and I'm laying it on its side. I'm laying it so it's like this. So now what I note here, if I just look at these two carbons, the one that's facing you and the one behind, that this right here, this blue is pointing up, straight up. And this one right here, this white, is pointing straight down. If I kind of twist it a little bit, it'll be the right geometry. There you go. So this is up and this is down. Notice that this is up in a direction going outward, and this is down in a direction going outward as well. So this is basically how it looks. You have a straight down, a straight up, and then on an angle up and on an angle down. So just keep that in mind. That's what we're going to see right now. So what we see here is that the ones that point straight up are called axial. They're axial bonds. So, and I want you to notice something. If I had to figure out where is the first straight up bond, look at my drawings here for a moment. You look at if you imagine a imaginary line right here in the middle. Now, if you look at the carbon here, this green carbon, notice how it's pointing up. And this carbon is going in the down direction. That tells you where to reference. So look at your ends. Now, if the carbon's up on the direction up, then that means its axial is up. And if carbon's kind of pointing down, then its axial is down. That's what we do. And equatorial is the opposite. But once you figure out one location, you could draw out the rest of the structure. I'll show you what I mean. So here we have it pointing up. And so the cool thing about this is that it always alternates. If it's up, the next one's down. The next one's up. The next one's down. Remember, this is staggered. All these carbons are staggered, which means that they're anti. Okay, so axial up, axial down. Axial up, axial down. Axial up, axial down. The key is if you take your pen, and this is important because when you see molecules, you'll do this. You could measure with your pen. Is your pen going straight up, or is it up on an angle? If it's on an angle, that's called equatorial. If it's straight up or straight down, that's axial. So watch. Equatorial, going up to this carbon here, we know axial's up, but equatorial's pointing down. But here's the thing. Again, it's on an angle. It's not straight down. It's pointing away from the molecule. Okay? So on an angle down. And the next one's on an angle up. And the next one's on an angle down. And then angle up and so on. Alternating back and forth. Angle up. Angle down. Angle up. Angle down. Angle up. Those are equatorial bonds. Now these are very different in their terms of the way that they have their potential energy. And we'll see that next. But I want you to see this. Now, what I did here, I draw two separate molecules as if one has axial and one only has equatorial. That's not the truth. The truth is if you bring these together, you will get this drawing down below. And the truth is when I made this on paper, this molecules, I just took them and I put on top of each other, and that's how I got to this down here. So that's why if you notice, this is a little bit darker because I took this one and that one, they combined together, I slid them on top of each other. That is the true molecule. And this is going to be your template. This is your template that you will put on your card. You will reference it through all problems that we do from this point forward in this section. So make sure you take the time, draw this out, and put it somewhere by itself. Have it on an index card or just on a piece of paper because you're always going to look at this. All right, now notice that by combining everything, each carbon, if I look at any one, I highlight it in green, the very top right, they have one axial and one equatorial. So that's, notice how the axial alternates and the equatorials alternate. All right, every carbon has this, one axial and one equatorial. That's the key here, okay? So I hope you could appreciate this now and recognize the bond types that exist. Now, what we're going to do next is we're going to understand how that translates to ring flips. What happens when something's axial after a ring flip? And that's what we're going to do right now. So let's go ahead and take a look at tracking a ring flip. Now, notice that my red carbon is axial up, straight up. I take my pen and I measure, it would be a straight line up. And my other one on the blue carbon is also straight down, axial. So these two are axial. Now, what happens after a ring flip? Well, you know how to do the ring flip in terms of the V upside down V. You alternate, right? So this is a V side. This is an upside down V. And so now it's an upside down V and a V. So that's the first thing to do, is to draw out the skeleton. So if you have a V and an upside down V, then you do the opposite. Now, watch what happens to the red carbon. When this, you have to think of the logic. This is going down and this is going up, right? So now up here is the blue carbon. And notice that its bond is down. Very important. It started down. It was pointing down. It still points down right now. It did not change its direction. It is still pointing down. Please burn that in your brain. Remember that. Before and after ring flip, you do not change the direction of the bond, but you do change the angle. Notice that if this is axial, after a ring flip, it's equatorial. And whatever is equatorial after a ring flip becomes axial. So this little diagram helps you with two things. Number one, how to track where the carbons are. Now think about it. This is going in a clockwise direction. So if this is 1, and now you know that's 1, you always continue clockwise from there. Clockwise is this way for you guys. So if this is 1, this is 2. Not that. This is not 2 up there because that's going counterclockwise. So you go with the rhythm of this change. So I'll do it one more time to